Hi, I'm an old guy and I do maths. And today we are looking at simultaneous equations with three variables. You do see these in high school. It's not too often that you're working with x, y, and as I say it, z coordinates, but you do see these in high school, and they can be solved in a couple of ways relatively simply. We're not going to look at the way in which they're solved by matrices here. Matrices are a subject on their own, but we will look at how you can deal with these in a pretty traditional way. Right, so for those of you who say Z, forgive my pronunciation, and by the way, that is a Z to distinguish it from my 2's. Okay, Z2. Okay, so three equations. X plus y plus z equals 2. 6x minus 4y plus 5z equals 31. 5x plus 2y plus 2z equals 13. Now, you'll see that I have put some little markings here. And what I am going to do is I'm going to deal with these two equations first. This is how you do it. You do this in parts. And you can see what I've done down here. I've kept 6x minus 4y plus 5z equals 31. And I've multiplied this equation here by 2 in order to eliminate the y's. And so this becomes 10x plus 4y plus 4z, which is why I put a line through my z, so that doesn't look like 42, equals 26. And when I add these, I get 16x plus 9z equals 57. The y's are gone. Okay. Now, what do I do next? Well, pretty much the same thing, but with different equations. So what I did was I multiplied the first equation, this equation, by 4, and I got 4x plus 4y plus 4z equals 2. So I'll just write that here. So that is x plus y plus z equals 2, and I multiplied it by 4. And I took the second equation, which I also used here, and I have a negative 4y in this, and you can see hopefully what's going to happen. I'm going to add these, and 4 and 6 will give me 10. The y's will disappear, and I get 9z here. So 10x plus 9z equals 39. And you will see that what I've got is I've got a couple of potentially simultaneous equations that I can work with. In fact, they've turned out brilliantly because I have absolutely equal terms here. And I can use these two equations, I have got equal terms here. I can use these two equations to find x. And that is my next task. So let's go to work. Okay, so here we are on the second page of working. And I've got two equations, 16x plus 9z equals 57, which I got from here. That's my first equation. And 10x plus 9z equals 39, which I got from my second equation there. And what I'm going to do is I'm simply going to perform a subtraction. So 16 minus 10 gives me positive 6x. 57 minus 39 gives me 18, so x is equal to 3. So what do I know now? Well, I know that x equals 3, so I can do a little subbing in. And what I'm going to sub into, I've just got this on a separate piece of paper, what I'm going to sub into is I'm going to sub into this equation here. I'm going to take x and I'm going to sub it in here, and I'm going to discover what z is equal to as a result. So 10 times 3, which is x, plus 9z equals 39. So 30 plus 9z equals 39. 9z equals 9, so z equals 1. Now we already know that x equals 3. So we've got two of the three variables. Just let me pull this page up here. We've got two of the three variables. And that means that we can go back to our original set of equations, and you'll notice that there's a really simple one up the top, x plus y plus z equals 2. And we can use that to figure out what our missing variable is, our unknown. So x is 3, z is 1. 3 plus y plus 1 equals 2. Y plus 4 equals 2. Y equals negative 2. And that is this set of simultaneous equations solved for x, y, and z. Now, that may well be sufficient. If you're into 3D graphing of these things, then the point at which these things meet in space is at x equals 3, y equals negative 2, and z equals 1. But that may well be beyond what you're looking at the moment. Anyway, it's a bit of information, and all information is worthwhile. Thanks for watching. See you again soon. Bye.